distinguished panelists, moderators, and distinguished personalities from NCET, NPUC, and NGI. And distinguished personalities from Institutions Innovation Council and ASHE to panel discussion on career opportunities in mechanical engineering. So I'm very much delighted to mention that today we got eminent personalities with us to conduct a panel discussion. We have with us Dr. H.G. Gopal Krishna sir, Director, Nagarjuna Group of Institutions. And we have Srikantamurthy sir, Principal, Nagarjuna College of Engineering and Technology. And we have Professor Nanjundappa sir, Principal, NPUC, Nagarjuna PU College, Elanka. And we have distinguished panelists. I'll put it as short and sweet possible. Mr. A. Madhukar, Regional Director, ASHE and CEO, Climatics. Refrigeration and air conditioning engineering with more than 25 years of experience in sales, service, design, project execution in the field of heating, ventilating, air conditioning, refrigeration. Worked in Messrs. Bharat Electronics from 1991 to 97 in plant engineering department with hands-on experience in various types of HVAC and R systems. We have one more distinguished panelist, Dr. Ramesh Pudale. He has varied experience in the field of product design, robotics, automotive design, and design research. Dr. Ramesh Shankar has been involved in research for the past 20 years. We have one more distinguished panelist, Mr. R. Srinivasan, Senior Engineering Professional with nearly 5 decades of experience in design, erection, testing, and commissioning of various engineering systems and engineering services. And we have one more distinguished panelist, Tennavarajan, Propulsion Division, CSIR, National Aerospace Laboratories. Tennavarajan Subramanian, born 21 September 92, is an aero engines research working in the Propulsion Division of Council and Scientific and Industrial Research, National Aerospace Laboratories, Bengaluru. Presently, he is working at CSIR NAL in design, simulation, and development of various aero engine components. We have one more panelist, J. Muniratnam. Mr. Muniratnam is an aeronautical engineering with a postgraduate diploma in management. He has over 30 years of experience in engineering space, right from project management to operational management and establishment of strong organizations. So we have one more distinguished panelist, C. Subramaniam, mechanical engineer from IIT Madras, past president, ASHE, director of SSS Consultant, Bangalore. He is a lead accredited professional offering consultancy services in the field of sustainability, green buildings, energy simulation, commissioning services, and lead facilitation, HVAC system design, intelligent building, automation systems, with an experience of more than 36 years in the industry. So, my dear panelists, and distinguished personalities from Nagarjuna Group of Institutions and faculties from mechanical department and all departments of NCET, students from all departments, I welcome you all to the panel discussion on career opportunities in mechanical engineering. Over to Dr. Kapilan.
Thank you, Mr. S. N. Raju, for the introduction. Now I request the panel moderator, Dr. H.G. Gopal Krishna, Director NES, to start the session.
Good morning, everybody.
Good morning, sir.
Respected panelists and the distinguished participants, students and parents who are also part of this webinar. It's a unique webinar wherein the career opportunities in mechanical engineering will be highlighted by the panelists individually. Now, under mechanical engineering, there are 3 pillars, namely manufacturing, thermal engineering, and design engineering. These are the 3 main pillars of mechanical engineering, and therefore the student participants also. There could be 2 sets of participants. Number 1, presently who are pursuing mechanical engineering. Number 2, students who wish to pursue mechanical engineering as their career path. So, with these few words of introduction, I request the panelists to start with the presentation. Can we go by the order or how is it?
Order on
Mr. Srinivasan, I invite you to present your views on the career path in the mechanical engineering, sir.
Okay. Thanks for inviting me. Thanks to all the the panelists for this view.
ఎప్పుడైనా పోయి ముట్టుకొని రావచ్చమ్మా నువ్వు విచిత్రం ఆడదు ఎంతనా
Can I?
The host should mute others.
Okay. Sorry.
No.
Shall I?
Yeah, you can mute others. That's better.
Mute others, is it?
Yes.
Okay, 1 minute.
No, you are muted.
You
are muted yourself.
So now nothing is.
Yeah. Host has muted everybody, sir. Yeah, you can go ahead, sir.
Now, okay, fine.
There will not be any disturbance. Yes.
Sure. Mechanical engineering, is always considered a profession, provides ample opportunities to build better future for self and the world, extending our physical abilities by applying mathematics and physics. This is, the cost of the mechanical engineering. The statistic shows 89% of mechanical engineers are satisfied with their profession. A significant, point in promoting the mechanical engineering among the students. With a wide spectrum of branches of mechanical engineering in concept design, production planning, manufacturing, quality and assurance, sales and marketing, after sales and service, installation and commissioning of plant and machinery engineering systems. The operation and maintenance, in all this, the operation and maintenance plays a vital role in upkeeping of the systems, equipments, and sustains its intended life. A mechanical engineer has a constructive role in reducing the life cycle cost of the equipments, engineering services, that is utilities, plant and machinery. Hence, this branch provides a huge career opportunities to the mechanical engineers. Comparatively, few of the mechanical engineers choose or rather opt this O&M, operation and maintenance, as a career. Many aspirants who take up mechanical engineering consider this O&M as the last option. In today's scenario, the O&M role is taken over by facility management organizations, with exceptions like manufacturing sector, process industries engaged in electronics, pharma, dairies, food processing, etc. Except these sectors, others actually considering it as a non-core operations, or which is not in the line of business. So they are opting it out, or rather giving it to the facility management organizations. Okay. What is the facility management? The facility management is an integrated system where all the stakeholders are collated through the interdepartmental coordination, human-machine interface. Mechanical engineering has a significant role to play in the chain link, and that is strengthened with every link. Mechanic, he coordinates with all the other stakeholders. Now, introduction to the Indian hospitality industry. See, generally, every mechanical engineer thinks about more of the manufacturing, more of the process, etc., etc. But generally, they do not. This hospitality industry as one of the options. But this industry has emerged as one of the key drivers of growth among the service sectors in India. Also, a potentially large employment generator, besides being a significant source of forex for the country. The India 2019 annual research report shows this industry has a contribution of about 9.2% of the GDP and provided 42.7 million jobs, or 8% of the total employment. Now, going by this, the projected investment by 2025 in this tourism and hospitality industry will be around 275 billion US dollars. There is a setback due to this COVID-19, but this industry will certainly revive and capture a dominant position. Going by the fact, between 2000 April to 2019, this sector attracted $12.35 billion of the FDI. Now, we talk about this hospitality and also, the facility management, as a career option. So, what is it required to become a O&M specialist or a successful O&M manager? One is the skills, to aptitude to learn, attitude towards the customer, fourth, people management. Compared to the other sector, this O&M sector, it requires the patience from the people who opt this career compared to the other areas. The reason being, the time taken to the time taken to get into these skills is longer than the other areas. Now, keeping this in mind, KSI is a charitable trust taken up this initiative and has launched a training program. The training program, is for the graduate engineers, or maybe a diploma engineers who have come out of the college, or maybe undergoing in the last year of studies. So they can actually, this is an option. So this option has got, about a couple of months of training with, the classroom training in developing their, giving the theoretical inputs of various subjects like, HVAC, electrical, etc., etc. Definitely, of course, if the participants or if there is a majority of the people who are interested to know about this program, there can be a separate program which I can just conduct and then speak about it. Since this is only a kind of introduction about the other options available for the mechanical engineer, just making a very brief introduction. And also I emphasize this is an area where most of the mechanical engineers are not opting for it. The reason being, it requires a longer training, and also the job is also, you say you have to 30 your hand, not like immediately you become a manager. With this, I just close with this remark, like, in a nutshell, a mechanical engineer mechanical engineer is strong in fundamental, with a logistical analytical ability, focus on sustainability, is always in growing demand with the challenging opportunities. I think this.
Thank you. Yeah. Thank you, Mr. Srinivasan.
Yes, sir.
Now, we will have the question answer in case if there is any doubt or question at the end of the session.
I'm here.
Yeah, that we will take at the end of the session.
Sure.
Now, let us move on to Dr. Ramesh now.
Okay.
Ramesh.
Yeah, thank you.
Good morning.
Good
Please
morning.
go ahead.
Yeah, so, I would like to share my, presentation so that, we can.
Okay.
So, I hope all of you can see my presentation. I'll just go to the presentation. So, with this, just give background. I look after Indian education program for in manufacturing properties, and today I'm going to talk about some the manufacturing skills which are very special for engineering students. Could you please mute? I think there's someone. Oh, thank you. So, the important trend is like, what are the trends as far as the mechanical industry is concerned? So I would like to give them the bigger picture on what are the trends which are really important. And in these trends, currently, if you look at India as a market, like we have more than 90 million jobs which are unfulfilled for the next decades, and this is due to this the skill shortage, and if you look at even construction industry worldwide, so this is the bigger number. I don't say it's like more than 200 million the jobs which are available by 2030. Now there is a skill gap, and we would like to address what are the big picture in terms of the skills, how the skill has to be taught in 3 dimensions basically of learning. So Autodesk really believes in these 3 different terms, which is basically a mindset, skill set, and the tool set. Now, if you look at the schools, when the teachers are teaching or the professors are teaching, so they are putting a lot of efforts in terms of their training on the conceptual content. So we have the lessons, and we go ahead with the lessons and the outcome. We use a different the concepts. We use the design thinking, sustainability, and there is the concepts in terms of applying these new trends in the learning content, because this is purely coming from the addressing what is a skill gap. Now, if you look at the industry and the disciplinary content, like the students should go ahead with different types of case studies, the industry interviews, what are the best practices, which are the advanced courses which are available, and these are basically industry focused courses. So these skills are really important, for everyone to understand what are those, the skill content or the disciplinary requirement. And then the another one is but the changes are, there's few changes. But the next thing which is called as technical content. So there is a huge drastic change after, I think, the post-COVID also we have, a lot of changes we might see. But there are a lot of new courses which are now available, how to do videos, and then specifically there is often changes in this tool set. Okay. And where the students needs to prepare with the industry requirements. Now, if I look at the industry, primarily for manufacturing or all of the era of documentation, we have started with the 2D, drawing. There are some jobs. You can see the titles like CAD technician, technical, and then in 2000 onwards, we are talking about the era of optimization, where there are a lot of new jobs which are emerged. Which is like, for example, the manufacturing engineer in technology or simulation engineer. And now 2015 onwards, this is the era of connections. So we really see these new job roles which are coming up, like for example, the model-based system or AR, VR engineer, generative design consultant. So these new roles which are coming up. And as far as the industry, trends are concerned, as a holistic, perspective, we need there is a huge pool of students we are required, right? And there are some large number of students who actually embrace the new technologies, and these technologies are basically based on the new business models that are evolving. And there are also some, purpose-driven agents also. We call it as the student experts, the student ambassadors on campus, so who can really contribute and, make the changes in their portfolio. If you look at the manufacturing and construction industries, the people, they don't go ahead with the approach, but the new jobs which are evolving, which they really pick up. Okay, and then some of the guys, go into the fields where they can also make their role models, and also they, try to do as a mentorship as well. The girls are also, coming into the manufacturing domain as well. So there is a huge opportunities for the girl, but it is slowly moving. Now, I would like to give one example about this new technology, like how the companies are evolving. Now, if you look at this, is the electrical car by GE. They are committed to launch this vehicle by 2023, and this car has something unique things, right? So they have adopted a new technology which is called a generative design. And this is due to because they have facing some challenges, like for example, they're facing challenges in terms of mileage improvement, reducing the battery weight, the safety and the lightweight considerations, or they also want to improve the customer experience and want to make it more affordable car. And that's why the technologies like the generative design is really playing an important role. So this is just one example I'm giving you. Now this is the technology is powered by AI and machine learning. So even if you see the simple bracket where the seats are fastened, so we take that bracket as in one example and try to optimize it. So the bracket which is designed by the system, it's completely different. So it has many improvements, which means the solution which the GM has designed is 40% lighter and 20% stronger than original. So the another fact of this bracket, if you see on the right hand side and this bracket, and on the left hand side, the bracket which is designed by the generative design algorithm, by Autodesk. So this is completely unique. The benefit here is you can save the number of parts, you can save the material as well, and you can use the new technology to make it more lighter and stronger as well. Okay, so with this thought, right, so I want to give one more example. I think, I don't know how much time we have. So this is the example which is about the racing car, and the racing car has a requirement in terms of optimizing this the part, which they go and look at into how they can optimize, what are the constraints, which are the manufacturing methods. So they give all these constraints, material constraints, and then they will generate a number of solutions. So these are all optimized solutions, and out of that we can pick which is the the cost effective, because in fact also we can see the cost as well. So these skill set really makes sense for students to go ahead, because this is not in the syllabus, and even if you look at the mechanical engineering syllabus, it's not updated to that level. So, and currently these technologies are playing a huge role in terms of reducing, optimizing the part, and using some hybrid manufacturing methods. Like for example, it's a combination of additive and subtractive manufacturing method. So how you can use these methods, because the way we design, the way we make those parts are changing drastically, and therefore we need to have these new technologies in the hands of the students so that they can effectively use and make their design decisions for their projects and for the company's projects as well. So this is something which is new and exciting because many of us, as Autodesk is a leader in this particular field, and you can see that the camp process and the technology, the platform what we use is completely integrated. So it has a completely CAD, CAM, and CAE background, and it will work on a Mac, on Windows PCs. And the best part is right now, due to this COVID-19, the people have started collaborating, right? So if there is a single assembly, the people have started collaborating with the multiple people, especially if you look at the NASA's laboratory. So we have done this fantastic project on this, the collaborative research on multi-manufacturing methods. So these skill sets are really important, and we especially, believe in terms of giving this learning content for all the students to use this on Coursera. We have Autodesk Design Academy. The students should really learn these new tools and new technologies quickly and get the certification. Okay, so that is a pretty old side. With this part, I'll just leave it to Krishna. Yeah, I just stop sharing. Yeah. So you're on mute, sir. Dr. Gopal Krishna, you're on mute. Yeah.
Thank you. Yeah. Thank you, Dr. Ramesh. You have rightly mentioned about mechanical engineering cannot be studied isolatedly, but AI, ML, all these are also embedded into mechanical engineering today. That means there is a lot of interdisciplinary studies taking place, including the biomedical engineering, the mechatronics, all such areas. The HVAC is another area. I request Mr. Subramaniam C. to put his remarks.
Yeah, a very good morning to all of you. Thank you for this opportunity given to me to share my thoughts on this career opportunities for students, because this is something which is always passionate for us to talk to students and give career guidance to them, because that is a dream for which they are studying. They have been studying right through the 4 years. The air conditioning and refrigeration, if you see as an industry, it is mainly relying on mechanical engineering students, mechatronics students, and with their electrical background, is a little bit of electrical background. Right from the morning, when we need milk and vegetables at proper temperatures, proper good condition, and right through the day when air conditioning is required from the place we live, either a residential place or an office, or we go to a cinema hall, or we go to a mall, or we go to a restaurant. This is a part of our daily life. That is why this industry is very vibrant. And the kind of, we have two aspects here. One is air conditioning, the other is refrigeration. On the air conditioning side, I'll tell you the industry is growing with a lot of urbanization taking place. Only there is a little bit of impact of COVID, but I'm sure that we will get across this scenario. This is a current challenge which is there with all of us. What is happening is, air conditioning industry, with the strong background of students in the field of thermodynamics, turbo machinery, which is pumps, fans, compressors, which they have learned, with the mechatronics and instrumentation people, they can enter the field of air conditioning and refrigeration in the stage of design of air conditioning system, in project execution of air conditioning system, installation, post-installation into service operation. We had Mr. S.N. Raju was mentioning about facility management. So that is a big opportunity because the life cycle of the equipment is almost 20 years. So every building needs proper facility manager. So these are the areas they can enter into air conditioning and refrigeration in the capacity of design engineer, project engineer, installation, site engineers, commissioning engineers, service engineers. So there is a lot of opportunity there. And then there is another big opportunity of project management in all these areas, because project management is a skill which the students can learn how to effectively, execute project, air conditioning and refrigeration project, because these are projects which span over one year or 2 years, the large scale project. And another very creative way, Mr. Srinivasan was talking about or not necessarily Mr. Dr. Ramesh, or he was talking about the Autodesk and the energy, the BIM models and all that. So there, what we have, there is opportunity for students to get into energy simulation. And that is where knowledge of thermodynamics will come into effect. They can become energy simulation engineers, get into green buildings design, where sustainability is a very, very important aspect for all of us today. So that is one area which the students have got a lot of opportunity enter into green building design, sustainability practices, energy simulation techniques, and these are the air conditioning part. On the refrigeration side, on the cold storage, there is a lot of opportunities in cold storage design, because that market needs air refrigeration. Refrigeration is the key driver in that area. Cold chain, cold storage, refrigeration services, manufacturing, design, there are a lot of opportunities in that. And in these areas, the students have to look at long term. They can start the career, and after 5 years, after 10 years, they can become entrepreneurs. So that is how I think the students' dream should take place. These are areas where they can definitely, be in their own place. For example, if they are based out of Bangalore, if they are based out of Hassan, they are based out of their local areas, they can start their own, franchisee, the dealership, and then they can execute, they can get orders from owners, execute orders, and then even sustain others. They can give jobs to other students as well in the years to come. So this is one area which is very vibrant, which is very growing. And there are a lot of internship opportunities which are there for students. For the going forward, or even now, the present students want to get into some internship before get into the project jobs. Those opportunities are also there. So air conditioning and refrigeration is a very vibrant field. There are lots and lots of opportunities, and this is relying on only one simple thing which they have studied, which is vapor compression cycle, thermodynamics, and the turbo machinery products which they have learned, fans, pumps, compressors, and also fluid mechanics, little bit of fluid mechanics. It's a very simple field. They can become masters in that field, and they can cut their own career. They can make a very good career in these lines.
Thank you, Mr. Subramaniam. It was very wonderful and informative. Yeah. I feel the farmers are suffering when they grow the product. At that time, they don't get the market price. So in case if they have to store the agricultural products, they definitely require refrigeration systems. If we can go towards the solar refrigeration system, which is independent of the energy, any remote village, this can be implemented, and therefore it has got a lot of application part. Exactly. So you have rightly mentioned that under the Make in India, the present system, the present government is initiating a lot of such entrepreneurship also. You have rightly mentioned that the students can take up the entrepreneurship also after 4 or 5 years of experience in the R&AC industry or air conditioning industry.
Yes, sir, definitely.
Now, secondly,
yes, sir. So definitely, there I feel they can work in the field as engineers, learn the trade, learn the industry, learn the skill, and they can start their own company, and they can do a lot of innovative products they can come up with.
Correct. Sir, there was a question from the students also that initially when they graduate, they don't get the job opportunities, but everybody will be asking for the experience. In that regard, you have rightly mentioned that internship is a solution. Yes, students should take up internship initially, maybe for 1 or 2 years. Yes. Then once they get the experience, probably they can jump to a good higher package salary. Yes. And after 5 years or 6 years of experience, they can have their own entrepreneurship. All these are the avenues. Thank you very much for your insightful talk, sir. Now let us move on to Mr. Muniratnam. Please throw light on the career path in the mechanical engineering, sir.
Yes, sir. Thank you so much. Thanks once again for inviting me. I've been asked to speak about two specific areas. One is opportunity for mechanical engineers in aerospace industry and automotive industry. I'd like to tell to the students here that mechanical industry or mechanical engineering is the master of all engineering, whatever I've noticed in the last 3 decades of my experience. Specifically, if you look at aeronautical field and aerospace field, 90% of the engineers who are working in our aerospace industry are all coming from mechanical background. So if any of the students feel that, no, I don't have an aeronautical engineering, then I will not get a job in aviation or aerospace. They did not have this apprehension. We have noticed that most of the mechanical engineers have done an excellent job in this industry. And the safest mode of transportation is aviation. So coming to the point of opportunities and different areas in aerospace, mechanical engineers, we do consider them as any other engineers in aerospace industry. Different topic. One is the aerostructural design, aircraft structural design. Some of the civil engineers do work on that, but we have noticed 60-70% are again coming from mechanical industry or mechanical engineering background. They can work on stress activities, design activities, CFD activities. Then there's another area called concessions. Once a product is designed, at that time of manufacturing, there will be certain gaps. At that shop floor level, you make the modification, do the assembly, then again give the feedback to the designers. That's one of the biggest area called concessions, which is happening specifically from India by most of the engineering services companies. Then some of the students can get into avionics if they have a flair for electronics, which is again an upcoming area. Now, Mr. Srinivasan has mentioned rightly that O&M, the operation and maintenance, we call it slightly different in aerospace industry. We call MRO, maintenance, repair, and overhaul. A product, once it's designed and put into operations, the life of the product is 30, 40 years. For example, aircraft engines would have been conceived 30, 40 years back, would have got designed for a period of 10 years. But once it is into service, they use it for 50 years. So which means for a product design, you need, let's say, 100 engineers, but to maintain that engineer, you need probably about 500 engineers. There is a tremendous opportunity in MRO activities, specifically in aerospace. I'd like to highlight here for the students, recently Government of India has taken initiative to give certain concessions to the MRO industry in India. Today, most of the aircrafts go outside India, get it repaired, overhauled, and come back because we are unable to do despite the cost advantage we have over the labor cost. But because of the certain customs duties and excise customs regulations, there is a cost is high, but that's being changed. What I wanted to tell you is the government is relooking at MRO. There will be a lot of MRO opportunities for which what these mechanical engineers need to do. For example, HAL has got management trainee programs. They have apprenticeship programs. If they want to get into aircraft industry, they can join as an apprentice, get trained there. Then either they can continue to work there if there is an opportunity. If not, they can go to many, many private organizations. As you all know, Bengaluru is called Mecca of Aerospace in India. Fantastic opportunities are there, small to big. And a lot of OEMs, international OEMs are present in Bangalore. In addition to that, HAL Academy conducts a couple of courses. One of them is called the Certificate Program in Aerospace Management. Then we have PGDEM, that is, there's a diploma course for about 15 months of program. So I think they can go to this HAL Academy and get trained. In addition to that, the government of Karnataka has set up a aerospace skill center as part of the Aerospace Skill Council. They also conduct a lot of courses. I think the students can get into this. Now let me come back to the automotive sector, what are the different kinds of opportunities our mechanical engineers have got. They can work on BIW. I'm not sure how much of exposure they get in their third year or final year programs, but BIW, CFD activities, then wire harness design, then robotics, manufacturing engineering. If these kind of topics, if they get exposed during the third year and the fourth year, there are plenty of opportunities within the service industry and manufacturing, automotive manufacturing companies in India. For example, I'm part of SAE. I'm sure most of you are familiar with SAE, the Society of Automotive Engineers, which is a 100-year-old organization. I head the aerospace board or aerospace forum here. SAE conducts a lot of programs for students, predominantly for mechanical students. And most of you are aware that BAHA, which is spelled BAJA, is one of the flagship events where about 8,000 students participate every year. I encourage mechanical students to participate in this. And in Bangalore section of SAE India organizes various programs. One such program is called REEV. I was spearheading that program, which got concluded a couple of months back. It's called Range Extended Electric Vehicle. The students should participate in such programs. It doesn't cost money, but a lot of mentoring happens from industry professionals. Again, within automotive, I would like to highlight Mr. Subramaniam spoke about HVAC. Many people don't realize that HVAC is equally important in cars. There are big players, Densos of the world and the Valeo of the world. They probably have 90% of the market for HVAC system in automotive. And all of us know that most of the cars come with the air conditioning system these days when you compare it about 30 years back. So students have the opportunity to work on these systems, especially the mechanical engineers. I think there is a lot of opportunity. I don't think students should worry about this COVID scenario. I think all the elders gone through that in the past. It's only a couple of months and maybe 1 year. But you have a lot of opportunities. I would like to assure you that. Thank you, sir.
Thank you, Mr. Muniratnam. You have rightly pointed out two sectors. One is the aerospace and the other one is the automobile. In the aerospace, generally the students have a myth that if they study aeronautical engineering, they can go to aerospace engineering. It may not be true. What you said is correct. Mechanical engineers play a vital role in the aerospace industry. Design of the aircraft or the turbines, the blades, the alternative material, composite materials. There are a lot of wide spectrum of the jobs available in that area. Yes. Thank you very much for that. And there was one more apprehension. If in case, training or internship has to be done after the graduation, then why graduation is required? There was a question like this. What I feel is graduation, particularly in mechanical engineering, the foundation engineering. So they learn the fundamentals of the engineering. Then secondly, their mind will be focused towards logical thinking. The logical thinking is applied in the engineering sciences, and therefore some graduation is required initially. Then they have to take up the training, particularly in the specialized sectors. In the specialized skill sectors, they can take the training and then they can shape up their future. Let me move on to Mr. Madhukar for your expert advice, sir.
Thank you, Dr. Gopal Krishna, and most of the panelists have expressed on the need of the hour, or probably what we call as way forward for mechanical engineers. In fact, I have been associated through ISHRE. I have been visiting most of these colleges who are our student chapters for the past 5 or 6 years. And it is really unfortunate that we are sitting here and discussing about opportunities, which actually I feel that the opportunities are not grabbed when the opportunities are given to them. Say, for example, I would like to, in fact, my own case, I am struggling for the last 5 years to get a marketing engineer for my company. The problem here is I feel it is the attitude, and I also feel that the students are probably thinking that I am an engineer and I will get a job on my own. So I think it is more to bring in terms of attitude that the students have to change and probably grab the first opportunity what they get, irrespective of whether it's a white collar job or a red collar job or whatever collar job it is. For example, now whenever I go to most of these colleges, where we do these kind of say some kind of technical talk or whatever it is from representing ISRE, that is Indian Society of Heating, Refrigerating and Air Conditioning Engineers, we ask the students, how many of you want to be a part of service department? Nobody is interested. I mean, I don't see any reason why, because today service technology has advanced so much that when you today say, for example, you have systems with variable frequency drive, you have systems with variable refrigerant flow systems, where in fact troubleshooting has to be done by professional engineers through, logging into your laptop. Either the ITI students get their levels raised to using laptop and come into troubleshooting, or we have to find diploma or engineers who can come in and fill in that bridge so that they can train the lower rank technicians who will be able to attend these kind of complaints. So before I move on further, I just have a small 4-5 slides presentation, which I would like to enhance on what Mr. Subramaniam and probably some part of what Mr. Srinivasan has told in terms of career opportunities. So if I can just share my screen, just give me a minute. Yeah, I hope everybody can see my screen. See, unlike most other fields, the air conditioning and refrigeration industry offers a wide range of career choices depending upon the individual's interest. Okay, then what are the career paths for us? We have in terms of marketing, in terms of design, that is equipment systems. It could be project designing, it could be testing labs, then it could be your manufacturing, maybe your assembly lines, factory for domestic products. And there are a lot of multi-brand companies, especially after Make in India concept coming in. A lot of manufacturers are setting up factories in India. Then you have planning and procurement at various levels in these manufacturing segment. Then most important, like what Mr. Subramaniam has stressed, and also Mr. Srinivasan also touched upon this, project management is, see, please note, every project site today needs at least an engineer or another 2 people supporting this project team. So there is tremendous opportunity for an engineer to get into this project management. And then again, post sales and service, like I said, this is an endless opportunity. Everybody day in and day out will have a requirement in service, not now, forever. Then the list of business, like we have refrigeration application. In refrigeration application, we have low temperature refrigeration, process cooling, CNC machine tool cooling, industrial refrigeration, domestic refrigeration. Then you have visi-coolers, you have cold storages. Coming to HVAC applications, you have unitary products, central air conditioning system, industrial ventilation and air conditioning systems. You have retail, malls, theaters, then hospitality, hotels, spa, gyms, hospitals and health centers, IT, ITES and data centers. Then probably way forward, we will have a lot of requirement in IT hardware, then R&D, nano and biotechnology, then simulation and training centers. I think Subramaniam and even our friend from aeronautical department touched on this. Then public infrastructure like your metros, airports, energy management. Then which are the associated industries? The associated industries are your project management consultancy, your facility management. You need to coordinate with a lot of architectural firms, then building management systems. A lot of things are getting automated now. You need to keep abreast with knowledge on building automation system. Then finally comes our design consultancy. And the most common thing, you go and ask any student today, what do you want to do? He will either say R&D or he will say design. He will never say, I want to sell or I want to get into servicing. Then, so you will also become master of all trades, because when you are handling a project or when you are coordinating with in designs with an architect, you will coordinate with electrical engineer, you will coordinate with fire systems, you will coordinate with building management systems, you will coordinate with a plumbing system, plumbing this thing, and you will learn to understand a lot of other trades also, which in some way or the other will help you benefit in terms of acquiring knowledge. So what are the culture of our HVAC industry? It is team orientation, performance orientation, constant learning, friendly open door, and long-term relationship. Every industry, like our friend from aeronautics department said, that is dependent on HVAC. It's a beautiful opportunity to learn all industries, their practices, technologies, operations, culture, competencies, and core values. An opportunity to grow as a person with an experience in all the fields. So now what does ISHRE do? ISHRE conducts a lot of technical talks. ISHRE conducts a lot of product presentations, conducts webinars. We do have e-courses. We do conduct something called as an advanced engineering diploma course for engineering students, which acts as a bridge course for engineering students once they come out of mechanical engineering. And we also grant funds for project development. And ISHRE has been leading the way for all these people who want to get into our HVAC industry. It's a premier technical society purely for air conditioning and refrigeration community, increased awareness on industry, new trends, and who are the players involved, which are the brands involved, excellent networking opportunities with industry professionals, meeting consultants, clients, suppliers, competitors, platform for effective marketing through exhibitions, conferences, then great source of information. You have e-learning, you have workshops. There are a lot of something called as technical blogs on our website. Somebody can pose a question where you get this thing, and employment opportunities, which I'm going to talk once I finish my presentation in a couple of minutes. Excellent platform for self-development, being a part of working committee, contributing and sharing your experience. And finally, this is what I had to present. Now I'll stop sharing. Coming back to the attitude of what I was discussing, like I think it is also sometimes that the parents also here need to be talking to their children on what kind of career they need to choose, because sometimes I'm also surprised that even an engineering student comes with his father or mother, and the first question they ask is, should my son go around in the sun during the day on his bike? Should he travel all around? So I think these kind of questions keep cropping up, and I also feel that the first and foremost, again I'm stressing, is the attitude of the student should be changed. And my humble request to all your academicians is that have some kind of a grooming structure right from probably the first year of engineering, where it gets into their mindset that it is not only IT or IT related jobs or white collar jobs that bring in their opportunities, but at the same time it is also probably the service industry, the marketing industry, and the outdoor activity like your project execution, etc., which brings in some kind of career guidance. That's it from my side, sir. Thank you.
Yeah, thank you, Mr. Madhukar. Let us hope some 4 or 5, which the number that we are looking for will come from this webinar.
I hope so.
To work with you.
I hope so. I hope so. I mean, okay. It is not any kind of publicity or something. It is just that, see, it is unfortunate that whenever I talk to any professional body of an engineering organization, they say that, I mean, somewhere I was reading newspaper that some 75,000 engineers are jobless. I mean, I don't see there is no opportunity. People don't want to take that opportunity. I would like to put it that way. I mean, if I were jobless, it is like beggars cannot be choosers. Whatever opportunity comes in my way, I would like to grab it with both hands. So probably I think it is again the mindset of the students which needs to be changed when it comes to opportunities that are available for an engineering student.
Perfect. Thank you very much, Mr. Madhukar. Let us move on to Mr. Tennavarajan for his expert advice.
Yes,
Mr.
sir.
Tennavarjan? Yeah,
Yes,
please,
sir.
please, sir.
Yeah,
Please,
one
sir.
second.
Yeah. Go ahead.
Yes. Yeah. Very good morning, sir. And first of all, I would like to thank for organizer for this webinar and head to mechanical engineering department, Dr. Kabilan sir, and director sir. And I have a few slides which I would like to share for the young people who can able to join for mechanical engineer, and what were they wanted to do and how they can progress in industry, as well as for the defense, as well as science and technology department, as well as aerospace department. Let me share my views in slides. Some of them I have made. Yeah. You would be able to see my slides, sir?
Yes, sir. Yes. Go ahead.
Yes.
Career opportunities in mechanical engineering. Yes.
Yes, sir. So it's very easy for me to handle in defense and R&D sectors, because I am worked for R&D and defense sector for more than 18 years. And what are the opportunities are available, and the youngsters what they can able to achieve by means of their set skill. That's what I would like to emphasize. And here for the basic students who come from PU or diploma candidates, the mechanical engineers covers almost everything under the sun. Something to do with mechanical engineers made by humans. If it is moves, if it is make something else, it transfers energy. So if you look at any component around you, it must be made by mechanical engineering role, so that everybody aware. And in mechanical engineering, we won't think about the sky, because we used to innovate, we used to create, and we used to always realize as a product. And we used to fly them in form of aircraft or spacecraft. So that's where we involved. And this is a basic slide I wanted to emphasize on youngsters, where the girls or boys, some of prominent mechanical engineers from women, where they have evolved the world by means of their innovation. So, and if you see in defense side, Professor Satish Dhawan from ISRO is the founder of ISRO, and his innovation, now there is a rocket which launches, and for the many applications for farmers or so and so like on. And we very well know that the Anil Kumble is also a mechanical engineer, and there are many top most mechanical engineers are available in India as well as in global, and you can be one of them in future if you come across with mechanical engineer. So the future requirement in mechanical engineer as a part of design and defense as well as aerospace, if you look in, the future case, the economic of future requires new human capabilities and capitals need to go into arrive by means of skill mismatch. This is what major thing we talk about it, because in defense sector we are a unique kind of nature, where we need to have a skill set of students or whoever joins in our organization. And if you go across in the future, it is going to impact on opportunities if you match with the set skill. That's what we are keep on talking, where we can get internship or whatever means, so that you can able to enter into defense or science and technology or R&D. The mechanical engineers always self-reliant, so they can take any kind of situation. That's what even this scenario, mechanical engineer can able to sustain in any kind. So these are the basic area I am going to emphasize on. This is covered almost all everything. The mechanical engineer can able to sustain in every field. At present in health center, as well as I am going to talk about on defense and aerospace center, and how we can enter into our field. So this picture also shows almost all everything where mechanical engineer contributes and their achievements in the field. And I am going to talk about the aeronautics, and in that field where we can able to get set skills. So this also what task do mechanical engineer can do, their career opportunity, like these are the basic needs they have to come across. These are the basic, even they can go through the subject in the same formula, and these all every industry will follow and to get final product. And at the current situation, the students can go ahead with software learning kind of importance, where our different sectors are requires and for the design and other form, like a cloud-based CAD system and conferencing software, ERP software for maintenance, and maintenance planning tool and remote desktop program. These are the program where in free time they can learn, so that they can come across and then they can join. And these also, these are main actually for the mechanical engineering who wanted to come across with the design field, kind of computer aided design and manufacturing and finite element analysis, computational fluid dynamics. In case of aircraft, we used to follow these standards to achieve the benefits. And this is the study, it shows where many of them called during this COVID situation and do the work and without any stoppage. Even our office we followed, and many of them did from their own home, doing by modeling software. 38% of people work, and simulation software 26% of people, and 27 about the top people, and the data management people also involved during this current scenario. And a similar kind it can go ahead in future also. And also these are the basic tool which students can learn, and so that they can come across with the manufacturing field or design field or whatever it is. And further they can bloom in this job market by means of exploring their startup ecosystem for job and improving additional skills in your subject and qualification, and whatever discipline you are come across or experience you come across, there you can able to add your additional skills so that you can fit into any organization. And if you look at the engineer needs, this is the major where we can, any point of time the people can adopt, like applied creativity, strong interpersonal skill, that is more important, and networking and leadership and conflict management, and interest to work with people. This is the main area where once people come into a company, first of all they will deviate in a single form or nuclear form, where they may not be able to produce anything. So when they come into college, this kind of set skills they have to set up there itself, so that when they come to company they can easily adapt. And by saying that, the actual product, what we do, one of the example I brought out here to show the mechanical engineers. So what achievement we can do. This is opportunity in aero engine and component design, fabrication and testing. And this is one of the component we have developed indigenously for aero engine, for high-speed aero engine. And this was the solution we were not able to bring out of almost about 20 years. Because of that, we could not able to achieve our speed. So here we indigenously developed, and it is equivalent to Russian technology. And this works for high speed about 27,000 RPM for 20 kg mass of shaft system. So it is completely test, and it is gone for aircraft engine system for its vibration reduction. So this is one of the example. Like this, there are many products, complex products we used to develop, where there are many mechanical engineers need their contributions in an innovative way. This and all, it's not a normal product. We used to develop our own, and we used to make a conceptual onwards and up to the end of testing. This is one innovative product. And this all everywhere, every industry has a CNC machine, as well as the defense and ISRO science and technology divisions will have. And we used to produce complex system like compressor, turbines, and so on products. But here in the system itself, CNC system itself, we used to use a lot of sensors in terms of to find out its condition monitoring in the tool as well as the product, so that you can improve in the product level itself. We need not go for qualification test, and further we need not reject the item. So because every individual aerospace components are very costly. So this is one more opportunity in aircraft condition monitoring program. where in our organization we used to involve in many programs with many employers. Like aircraft condition monitoring program, we have major program called engine condition monitoring. This also vast area where it is a lot of enormous manpower is required to achieve this kind of situation, as well as this is one successful program for our SARS activity. So I did not put this our own aircraft because of some complexity in outside showing. So that's why the basic view I have shown here. And one more, this is the aero engine which we use for our aircraft. And here also we have a lot of opportunity in terms of engine health monitoring and trend monitoring and integration and testing. So and the engine level as well as the flight performance level. So these are a lot of opportunities are there in these areas where the mechanical engineers can contribute and they can show their innovation. And coming to current situation, virtual job fair take place online. Actually, many of the virtual job fair from LinkedIn or many ways we can enter into. For that, the mechanical engineer has to prepare, and they should be dressed for success and check with the resume and check your technical skill. That's what right now there are a lot of lag from technical skill. Whatever the student comes from academic directly may not fit into the industry. So they need to get many the software skill as well as the technical skill so that they can directly come into our line actually. And almost all we know that the robot mechanized human is actually help for save people and current situation, and we use for surveillance purpose. Now we are move on for healthcare centers to provide support by developing robots and drone we use many of the applications for surveillance purpose. Now you know that in many places this is one of the major thing which is happening in healthcare center for surveillance also. So at last, the mechanical engineer should come up with the innovations wherever they set into, and they should have a skill set. So as we talk about now with this slide, whatever I come across, those set skills will help completely. And if they are self-reliant, then they can become an entrepreneur, and they can become a own startup also. They can make it. For example, I am doing my research on aero engine, where one student came and proposed the banana fiber can be used as a composite material for some cold air condition. So he brought that idea, and he made some small product and shown, and now he made one separate company actually. So like that, many way they can small thing can create bigger thing. That's what the students should understand, as well as they should act for that. So this is the everybody knows the situation is very unavoidable condition, but it will go away. But in CSIR and other our R&D organization immediately put up our effort to make face shields and portable ventilators, the antimicrobial coating on surfaces, 3D printing technology for 3D wall for the 3D sanitizer stand and door handle, as well as printed mask. So these are the immediate contribution by means of support the normal people. That's what we did in some of the area. And with this, I conclude my presentation with some remark message. Teamwork is mainly mind to achieve series of desired outcomes with many success. So that's what I wanted to convey. And one more thing, the present scenario, environment is very important. So mechanical engineers, wherever you contribute, it should be effective. Don't waste anything. So whatever you produce, the waste part of it, directly it is going to impact on environment. So please save natural environment and for keeping yourself health and safety. Thank you.
Thank you, Mr. Nagarjuna.
Yes.
Now, recently we conducted one webinar. It was a 5-day webinar on which we had covered a topic like agile manufacturing electric vehicles, robotics and automation, CNC machines, such things. And I'm very happy that you see a lot of applications are coming in, particularly in the defense sector. And recently we have read that even in the army and air force and things like that, drones are in place. They are going to use drones and probably controlled drones and uncontrolled drones. All such things may happen. So there are a lot of such opportunities available. Now, one of the question is that if a student wants to decide and pursue mechanical engineering, which stream they should pursue? Should they take up design, manufacturing, or should they take up sales and marketing? Should they take up such manufacturing? Which area is most suitable? That's what a question is. Can any of the panelists answer this? Yeah. Yeah, Subramaniam, you can answer, sir.
Yeah, see, one thing, Dr. Gopalakrishna, I would like to advise the students. Number one is they should look at their aptitude. You know, everybody is not, not favored for doing a marketing job or a sales job or whatever. If some of them are naturally inclined to do that. So they should, if they know that there is a flair for them for sales or marketing, they can readily take up that job. Now, if some of them are interested in research work, for example, doing a lot of computer coding, energy simulation, some kind of, they should understand their, best area of interest. If it is possible for them to get an opening in that, they should do. Otherwise, they should keep the opportunity open, accept the job, and then learn it, and then keep on and keep shifting. But, as the saying goes, rolling stone gathers no mass. They should not keep on changing the job every 2 years. The minimum they should stay in one job for at least 4 to 5 years, learn the trade nicely. This is my simple piece of advice to them. Learn the trade and then understand your area of interest. As you go, be sincere to your job, but you also discover what is your area of interest. And then if you want to reorient it, not an issue, but be sincere to the profession and then learn it and do it.
Thank you, Subramaniam.
Thank you, sir.
Yeah. Under Industry 4.0, what additional skill sets the mechanical engineering student should have? Can any of the panelists throw light on this?
This is Muniratnam here. So your question is under Industry 4.0, what mechanical engineers should learn?
What skill sets, additionally they should learn?
Yeah, see, Industry 4.0, there is a lot of misconception. It is not a singular technology. I'm sure all the panelists and yourself are quite familiar. So for the sake of students, I just wanted to highlight.
Correct.
But Industry 4.0 is nothing but the culmination of each and every department and each and every technology. For example, I'll just give an example of one small industry in Pina. Maybe I'll just switch on the video as well. I just would like to give an example of one small industry in Pina. They have been manufacturing components for aerospace using CNC machines. Now, each of those machines are independently, it just acts as an independent machine. There is no connectivity between each machine. Now, what this gentleman has done is, he has got some electronics background, but doing a mechanical job. So he put some kind of a PCB boards and connected all these CNC machines, which means we are collating the data from each of these machines. When you are collating the data, once the data is available, you can monitor the data, performance of the machine, the loading of the machine, how quickly the next job has to be loaded and things like that. And let us say there is a software built behind this. So all these things put together is nothing but Industry 4.0. You can expand, of course, Industry 4.0 to multi-levels. Coming to the question of what skills a mechanical engineer need to understand is how Internet is used in the manufacturing industry. That's one. He can also understand what is the supply chain, what is the complete engineering cycle, the entire life cycle of the engineering product development. If he understands that, and with this technology tools, he or she can get into Industry 4.0. In addition to that, now a lot of the software OEMs like Dassault and Siemens, I'm sure probably Autodesk also, are providing platform to Industry 4.0. In fact, about 8-10 years back, people were calling PLM, Product Lifecycle Management. Similarly, now Industry 4.0 has come. So I think mechanical engineers should understand complete supply chain, design process, and some electronics and software tools. I think that's a fundamental requirement. Maybe others can also add.
Yeah. So one of the point I would like to add here is Industry 4.0. Where there is an integration of all the systems. Like for example, if you look at, as I mentioned in my presentation, is about the generative design, which means the student should learn this technology, to come up with some new design. And at this, even for example, in the second and third year, if they are exposed to this technology, they will get prepared for their project as well as the ready-made resource for their the upcoming industries. And these technologies, the tools will keep changing. In the up of the pyramid, if you look at that, the tools are continuously changing. Okay, so the students should keep a pace, right? They should continuously start learning the new technologies which are coming into the market.
Thank you, Ramesh.
To add like what I was mentioning, we have various courses. If somebody wants to pursue their career in HVAC industry, ISRE has a lot of courses, including online courses as well as classroom courses. We have something called as Advanced Engineering Diploma course, which I said is a 3 months classroom course plus 1 month internship. And so far we have done about 4 batches, if I'm not wrong, from Bangalore chapter. And all the 4 batches, about 30 students is the maximum what we take. And all these 120 students are placed. It is not that they are jobless. That is point number 1. Point number 2, if somebody wants to pursue their career in design or somebody wants to pursue their career in service, we have something called as ISRE Certified Professional, which is a short-term course in design. If somebody wants to specialize in service, we have something called as ISRE Certified Professional for Service. And then we have for clean room. Then various courses are available, which if a mechanical engineering student wants to pursue his career in a particular set of industry, I think probably I'm sure there are a lot of bridge courses that are available which they can do. And immediately I think their chances of getting the job opportunities are more.
Okay, thank you. There is a question. Is it right for a mechanical engineering student to take up a job in the software industry? You can throw light on this.
If the question says, is it right? Probably we don't know. In fact, probably they will do justification in software as well. That has been proven. But unfortunately, they will be doing injustice to the mechanical industry. A good mechanical engineer, if he moves to software industry, I'm sure they would do wonderful justification, but we would also lose a good mechanical engineer in the mechanical industry.
Just to add some thought into it. Sorry. Just to add some thought into it, because the question of IT has come in. A lot of my friends are also into IT industry, or probably our own batchmates or something. See, at some point of time, you become stagnant there. There is no further growth available in IT industry unless you get into some kind of MBA or some kind where you get into the management part of it. Otherwise, you get stuck at somewhere called as your project head or team leader or your general manager or maybe even your director IT services. But beyond that, you may be getting a healthy package increment year over year. But at some point of time, there is nothing new for you to learn. You are under the same pressure. You are given about 40 people to manage the same project. And beyond that, there is nothing. So at some point, you have to realize that what is my educational background? And if I would have pursued, it's like a 3 Idiots movie. You need to pursue your passion more than actually the opportunity what you get in terms of getting into computer science, because somebody offers 60,000 rupees salary, somebody offers 70,000 rupees salary. I think we should again come out of these kind of things and see where actually 20 years down the line, what we would be doing.
Dr. Gopalakrishna, I just would like to add to what I mentioned about mechanical engineer getting into software industry. The mechanical engineer can get into software, banking, finance, sales and marketing, everything. On the other hand, let's say, can any mechanical company will recruit a pure software engineer? No, they will not. So I think the opportunities are. No, we have seen banking industry, IT industry, the service industry. Everybody takes mechanical engineers. I think there is an inherent analytical abilities. When you're getting into engineering itself, I think that the kind of honing happens. I think they get into this analytical ability. Maybe because you take a file and file a metal piece, that time you learn a lot. Yes.
I think Dr. Gopalakrishna, I think what happens is mechanical engineer is all set to, he has got a very comprehensive idea of everything. And he is very adaptive. They can take any branch of engineering and go forward. Whereas the other thing doesn't happen, as rightly said by Mr. Muniratnam. Software engineer doesn't come and join manufacturing or anything like that. But even in mechanical engineering, for example, energy simulation, I am sure Dr. Ramesh will agree with me. There are a lot of opportunities for young engineers to learn new ways of simulating the building, doing a 3D modeling of the building, architectural model, thermal model, doing energy simulation. And they should start looking at doing things on their own. After 5 years, 10 years, they can be their own entrepreneurs. They can start their own companies.
Yeah, I think the digitization is the way forward. I think everywhere, the students are, learning this, different tools.
Yes.
But there are huge opportunities because these are keep changing, and
Yes.
therefore the students should reskill and upskill on the new technologies which are coming in the market.
Yeah, there are a lot of things are happening on artificial intelligence and simulation, but they require mechanical engineering core concepts. You're talking about daylight study, wind study, CFD analysis, thermal modeling, even for operation theaters, how the temperature profile is there. You can't expect an IT professional to do, because for them, the thermodynamics is a black box for them. They don't know. Whereas a mechanical engineer, he learns a little bit of software on programming, and he can become an all-round engineer. I think that is where they need to reorient. And they have to now start skilling themselves with artificial intelligence, CFD modeling, thermal energy simulation. I think that is the way forward. They've got great opportunities in those areas.
Yeah, I agree with this.
Yeah, lot of automation is automation is going on in the mechanical industries.
Yes.
So therefore, yes, it is better that the students get exposed to the latest technologies like the artificial intelligence or the computational fluid dynamics, which you were mentioning. Yeah, all these are the tools and the skill sets which probably the students should strengthen.
Yes, sir.
If they want to. Yes, sir. Yes, sir. Please go ahead.
One more thing, what happens, there is a lot of IoT happening, Internet of Things. But Internet of Things are, being done by IT professionals, whereas it should be done by the core mechanical engineering professionals. If, for example, you want to manufacture a temperature sensor with an IoT device, the mechanical engineers can do, rather than ask an IT engineer to do that. They can only do connectivity and networking. But whereas mechanical engineer, mechatronics engineers, they know what is instrumentation, they know what is measurement, they know the importance of temperatures, pressures, and so many things. I think they should slowly start getting into artificial intelligence. It should not be a subject of IT and computer science. Artificial intelligence should be a part of mechanical engineering. Somewhere they should start learning it, during the summer term holidays, integrated with their core engineering concepts.
There's one more interesting question, Dr. Sir. There's one more interesting question. that during this COVID situation, medical profession never had any lockdown and they were making huge profits. But I would also like to state that even mechanical engineers, even our HVAC industry, we never were locked down during COVID. In fact, we were the busiest people once we came out of COVID, because everywhere you see people were talking about, can I run my air conditioning system? Can I do this? Can I do that? And in fact, ISRE worked overnight. There were a group of about 13 TGs who worked overnight in the span of 15 days to bring out a document, which it was a comprehensive document which brought in about guidelines to use air conditioning system during this post-pandemic situation. So that way, I think there are a lot of industries like that which never stopped working. So probably I think it is what is given in the media may not be right or may not be true also. Like for example, anybody who is into air conditioning maintenance, for example, there are companies who maintain pharmas, there are people in facilities management who maintain hospital air conditioning system. How does an OT work without air conditioning system? It is not that without these support services that any industry is going to be successful. It is probably to look at a broader sense.
True, Mr. Madhukar. I agree with you. Yeah. Yes. Today, wherever you go, there is air conditioning available, including a barber shop or a textile showroom. You take any such thing, you go to a hotel, everywhere you have the air conditioning in place. And particularly during COVID, if you switch off the air conditioning unit, that was the advice initially given. The central air conditioning unit should be switched off because that is one of the cause of spread of the COVID. So under such circumstances, if they switch off also, after 1 month or 2 months, if they have to start, they require your help.
Sir, which is exactly not true. That is what I am trying to tell. The air conditioning system, that is what I said. A group of about 13 to 15 people brought out a comprehensive document. It is even now available on ISRE website. You log into www.isre.in. It says COVID guidelines to start a HVAC system or guidelines to use a HVAC system. Nowhere it was mentioned that virus is spread by air conditioning system, which is actually not true. See, at some part, first of all, there were a lot of confusion whether this virus is airborne, whether the virus is not airborne. So people didn't know, and whatever came into media, people just started believing it and spreading it without actually knowing what the facts are.
Correct. Actually, there was a lot of uncertainty, sir, because there is no proof for all these things. See, even today, there is uncertainty. For example, when this COVID will go away, can anybody answer this? No. We don't have a definite answer. Will it go next day? Will it go after 1 week? Will it go after 1 month? Nobody knows. So therefore, there is no precedence. And therefore, there is a lot of uncertainty and hence, lot of apprehensions and ifs and buts are shown by many people. Yeah, Subramaniam, you want to say something?
Yeah, see, but assuming that the virus is there in the air, for the virus to be ineffective and for virus concentration to come down and virus to be taken away, you need a proper ventilation system and air movement, which can only be provided by air conditioning system. So what is said is it may be airborne, but not to an airborne to a great extent. It gets transmitted to some extent. But to dilute that, you need to ventilate. You need to have greater ventilation. And that can be provided only by air conditioning system.
And somebody started talking about HEPA filters. I don't know from where that word HEPA filters came in. People started calling and asking, I want a HEPA AC fixed to my house AC. It is just that not realizing what it is about. So, why we are talking about all this today, in spite of COVID being there during this pandemic situation. Also, I would like to say mechanical engineers always did have some scope somewhere or some role to play somewhere, and rather than not sitting idly at home.
I think we are getting a lot of questions. I think Dr. Kapilan is putting some questions.
Yeah. Kapilan, can you? Yeah.
What he says, if you are an entrepreneur, on what criteria you will select mechanical engineer? What work you feel that only a mechanical engineering can do? See, entrepreneurs, I think their point of view is, they want sincerity from the student. If they accept the job, they should be in the job at least, as I mentioned, 3-4 years. They can leave after 3-4 years, but not after 6 months, not after 1 year. Rolling stone gathers no mass. They should learn the trade and then they should decide. And see, the subject can be taught to them, but not the attitude. I think attitude wise, they should learn the ethics and then they should stick to one job. That's my viewpoint. Others can
add on.
There are a number of questions related to training.
Yes, sir. Yes, sir.
Shall I?
Please answer, sir.
Yes, sir.
Please go ahead.
So, what is asked? What type of training? The training, what we are actually, looking at, the training into the areas of operation and maintenance. The guys who gets trained into this operation and maintenance, has got an opportunity, job opportunity in utility departments of process, food industry, drug industry, dairies, etc., etc. Facility management companies, project management companies, as project coordinators, MEP projects of commercial, the IT industry, hospitality, and hotels. Then the next question is, what is very important to take up this training, some training? One is, as number of people have mentioned, the attitude and the aptitude. Attitude is because since this is an operational management areas, everyone deals with a customer. Whoever comes to the department is a customer. He has to be treated like that. So he may be however high, however low, it has to be approached as a customer. So the right attitude, to listen. That's number one. Then the aptitude to learn, because this is an area where the learning never completes, and always there is an opportunity for people to pick up. Because maybe supposing they enter in a software or whatever it is, and everything is fixed, then they just go on to the job and start doing it. Whereas in the operation maintenance, every day there's a new system coming into it. Every sector, be it a boiler, be it a generator, be in the HVAC industry. In fact, HVAC industry, the development what was there in 4 years is not a development. Today there is something else has come. So this operation maintenance engineer always have to be well versed with all the systems, which are all in place. So which means that is the aptitude. Then the third is the knowledge. The knowledge is the primary, capital for an operating maintenance engineers to succeed. Knowledge. And people management. So all these 4 areas, makes a successful O&M engineer. He rises as a head of a O&M department or maybe a future consultant. And now, the training, what we are just looking at, the training is about 3 parts. One is there will be a classroom training, which may spread about 1.5 months in all the subjects, starting from HVAC to the sewage treatment plant, water treatment plant, cold rooms, all that, project management, everything comes into that. Then they undergo the industrial visits, cold room factories, maybe DG service centers, and then the hotels, the kitchens, all that. Then there's an internship of about 1.5 months. This 1.5 month internship is, put in the hotel mainly, so that they get trained, in all the areas of, because the hotel has got everything, starting from the interior to the sewage system. They have got various disciplines. So the guys, gets trained, including the updation like BMS, etc. So once he gets ready, he becomes, ready to work as a trainee engineer in various places, including as a project coordinator in a project management companies, because the graduate engineers will easily fit into that. Mechanical engineers will easily fit into a lot of, the projects. See, one is your technology will change. So many things, like, automobile, gas becomes, solar, run automobiles, all that. But everywhere you need the buildings, you need all the engineering systems. So the guy, who gets trained can take up any of these assignments. So I think I have answered, many of these questions.
See, there is one question. Can you tell what are the different types of softwares you can learn while doing mechanical engineering? Mr. Darshan has asked. From my side, I would like to say that on energy simulation, they can learn a software called eQuest, which is a freely downloadable software from Department of Energy from US, CFD modeling tools and all that. And if there are some courses being run, the software is called eQuest, and that can be easily learned by them. There are a lot of videos available and help videos.
Dr. Ramesh also has posted.
I think Dr. Ramesh also.
Yeah. Can you highlight on that, Dr. Ramesh?
Sure, yeah.
You have said Autodesk Fusion 360 degree.
Yeah. So this is going to be a kind of latest tool based on all cloud technologies. It has all AI, machine learning, in design space, and currently as the number of customers which are increasing on this particular platform in India and abroad, and the software is completely adopted by many OEMs right now. The companies like, for example, let's say Hyundai. And Hyundai has designed the ventilator, sitting at home. All these designers who use this technology to build that. And currently in India, it is becoming really popular tool because it has all the facilities, which means it has CAD, it has CAM, it has TAE as well, and everything is integrated. Now, currently, with the help of Python programming, it's becoming really possible to interact with the software, write different app on top of this, and become the owner of the his particular own app with his own IPA. And also the another important thing is now these apps, the students, even new entrepreneur or something who wants to go into a startup business, so they can sell these apps on top of it. It is purely used for design automation. It could be used for let's say for thermodynamics, or it could be used for different industries. So there's a lot of automation which is required. And if the students can able to do that, it is going to be great help for. In fact, we have the dedicated portal which is called as Autodesk Design Academy, where we have given access to this technology with the certified courses free of cost for the students. So the students can go online on Autodesk Design Academy and complete these different types of courses based on the discipline, which is completely customized courses. I would say it's completely modularized, in for different industries. So, and these certifications are the international certificates assigned, or it is, offered to the students, and those credentials will really help them, bringing their portfolio, to some standard.
Yeah. So
there is a question here by one of the participants that IT companies do mass recruitments, whereas the mechanical industries do not do that. Why?
See, IT. Yeah. Okay. Traditionally, IT companies in India are more of a back-end offices, which means they need repetitive jobs to be done and a large batch processing. That's where they're recruiting number of people. But having said that, it is not true that mechanical industry do not require large number of people. I've seen the growth of Daimler Chrysler in India, which now it's called MBRDI, Mercedes-Benz Research of India. They started with 10, 15 people. Today they have about 3,000 employees, just direct employees. In addition to that, they also have indirect employees. So is the case with Honeywell. So is the case with Rolls-Royce. And even the IT companies are recruiting a lot of mechanical engineers for their mechanical activities. For example, TCS does work for, I think Humpty number of mechanical industry. I think it is the myth saying that there was a time they were recruiting in lot numbers, but not anymore. And there are only few Very few IT companies, but if you look at the mechanical companies, plenty of them are there. So I think cumulatively, I think it is equal. It is not that only IT companies are recruiting mechanical engineers.
I just want to add here, the roles which are available right now in the industry are completely changing. Because there is no currently role like someone can just parse out and go into the mechanical industries. I would say the skill sets which are required for these roles are completely different. And if you see the job roles and the responsibilities are also completely different. So those jobs were not available in the past. Now, due to these situations as well as current change in the industry, Industry 4.0. I think those changes are or those skill sets are really important for the students. I think students should look at those skill sets quickly and learn as soon as possible so that they will become more active to the new change.
I think, sir, the time is running out. Thank you very much for all the panelists for having joined. Now, a final question to each of you. If a student has to take up mechanical engineering course as the career path, if they want to study mechanical engineering, give one sentence. What could be the reason for them to select this branch of engineering? Each of you can say one or maximum two sentences. Let us wind up after that. Please,
I'll
one
give
by
my
one.
first statement before somebody snatches the statement.
Okay.
I keep telling the mechanical department or mechanical engineering is the master of engineering. Multidisciplinary. That's it.
Yeah.
Thank you.
From my side, Dr. Gopalakrishna, it is a very comprehensive, all-encompassive. It addresses all aspects of engineering. It lays the foundation for all branches of engineering to be specialized.
Next.
From my side, the mechanical engineer can handle any kind of job and they can able to join with any such challenges. So the best is mechanical engineer is a part of interdisciplinary also, and they can able to adapt easily with the industry. So they can choose mechanical engineer.
Very good.
Life never stops if you are a mechanical engineer. It keeps it always in motion. You keep moving.
Absolutely, yes.
Very good. Okay.
Never stops. Opportunities never stops.
Mr. Srinivasan?
Actually, I think all the panelists have expressed, and I am one of the passionate, in mechanical engineering. My favorite area is, the project operation and maintenance. The only issue is the parents and the students have to look beyond manufacturing, the marketing. Leaving these areas, they should also look at this particular area where the prospectus and growth will always be there, provided they are patient and they pursue the logical end. That's it.
Dr. Ramesh?
Yeah, I think from my side, mechanical engineering is versatile and it's adaptive and we can continuously keep on learning.
Thank you, all the panelists. In the end, if a student has to take up mechanical engineering, today we have covered wide spectrum of the industries, right from the project management, project planning to HVAC industry to the defense sector and the software industry, Autodesk and such things. The student should understand if they see any product in front of them, be it their mobile phone, be it their laptop, be anything they see, if it is moving, it is made by man and it is made by a mechanical engineer. Therefore, mechanical engineers are involved in every nook and corner of the society. Any product you take, any services you take, the hospitality industry they were touching, there again, if you see, mechanical engineers play a role there. It is not just the air conditioning or refrigeration that we talk of. in the hotel hospitality industry, the fire safety services, the wastewater treatment, the drinking water facility, all such things. There are a lot of such avenues where the operation and maintenance of these systems, once in place, need to be attended to by a mechanical engineer. So therefore, you take the defense sector, for example, we mentioned about the drone and the robotics and things like that. China and America, the other day there was a press news that they are coming out with a lot of such drones which can be used as bombers. So it is applicable everywhere. A mechanical engineer is involved in the manufacturing of a drone also. The software that is embedded onto that can also be written by any engineer, but then the manufacturing of the drone, which material has to be used, which composite material has to be used, what should be the strength, what should be the load that it should carry. Can it carry 20 kgs or 50 kgs? See, that way a mechanical engineer should decide. I think we have a lot of applications, be it the automobile industry, be it the aero industry, be it the hospital industry, hospitality industry. Everywhere we see mechanical engineering applications. And therefore, the importance of mechanical engineering is very much in the society. Therefore, with the available new technologies that is coming in, be it the artificial intelligence or the machine learning or the CNC programming, robotics, e-vehicles, electric vehicles, you take any of these, there is a role played by a mechanical engineer. Therefore, it is very apt that mechanical engineer is the master of all branches of engineering. The three foundation branches are civil, mechanical, and electrical engineering. These are the three fundamental branches. Out of that, one of the leg is mechanical engineering. It is also serving to the society and the mankind. With these few words, I thank each and every one of the panelists for accepting our invitation and participating in this webinar and sparing your valuable time and the knowledge, especially that you have gained over the years. You have shared it with the youngsters and the parents who are watching this. Thank you very much for all the help that you have extended to the society. Thank you, sir. All the panelists.
Thank you.
Over to Dr. Kapilan. Is there a...
Yes, sir.
Yeah.
Actually, till now, around 428 participants attended the live streaming through YouTube, sir.
Very good. Okay.
How many, Kapilan, sir? How many?
428.
Wow.
Very good. Okay.
Oh, great.
Since we felt that there will be a disturbance during the online session, so we kept it live streaming also, so that audience also will not be having disturbance and the panel members also will not be having any issues. So it was successfully completed with your support. On behalf of Nagarjuna College of Engineering and Technology, as well as the Department of Mechanical Engineering, I thank all the panel members for accepting to be a member of today's session. And I thank Dr. G. Kopalakrishna sir, Director, Nagarjuna Education Society, for moderating this panel session.
Dr. Kapilan, I have a word here. If there is any doubt among the participants, if they need any help, if they have any doubt to be cleared, let them send a mail to you. Through you, you can send it to any of the panelists so that they can reply that.
Yes, sir, I will do it.
Yeah.
I'll text it in the YouTube so that whoever have doubt, they can send the email to me. I'll forward to the concerned person.
Correct. Let it be a continuous process. Let the benefit go to the students.
Yes,
Thank you. Thank you, sir.
Thank you. Thank you,
Thank
sir.
you.
Sir.
Okay, thank you all.
Yes, sir.
Kapilan.
Thank you.
Yes, sir.
Yeah. Is there any this one video streaming or something like that now?
Yeah, what is that? 1 minute, I'll share it.
Yeah.
2 minutes, I will share some videos about the department. Then I'll...
Please share that. Please share that. Let all the panelists also are here.
Yes, sir.
It is for the information of all the panelists that we have a lot of MOUs, lot of funding also we have in the Department of Mechanical Engineering.
I have one suggestion, sir, Dr. Gopal Krishna.
Sir, please, sir.
This is Muniratnam here.
Yeah.
Due to this COVID, the entire the country has suffered in various aspects, and most importantly, this laborers in the construction industry have moved away. Whenever you speak to them, they say there is a shortage of about 80% of the laborers are not there. Is it possible for a college like yours to take up a small automation project? When I say automation, for example, I've seen a lot of videos where some of them come from China, but I'm sure even in India we see a lot of interesting videos where brick movement in the construction site, just a couple of bricks, not the entire bricks in a lorry, but about 30 bricks. How do they move it mechanically? How do they do the plastering mechanically? How do they do the tiling, layout of tiles mechanically? Can such projects be taken up so that we don't feel the shortage of these physical laborers?
I think definitely yes. One information I would like to give here to all the panelists and to Muniratnam.
Yeah.
Our promoters are the Nagarjuna construction company.
Yeah.
They are into construction, and if we make a machine, now a plastering machine you are suggesting.
Yeah.
In fact, I would like to mention here, with the funding from NCC, Nagarjuna Construction Company, we are into making one unique machine for the pothole filling. See, when we build the roads, due to the bad environmental conditions, definitely the roads will have potholes. And these potholes, it is very difficult and it is a slow process if we take up the filling up of that manually, number one. Secondly, it also disturbs the traffic movement. So therefore, therefore what we have done is, we have used a 3D printer and we are assessing the volume of the material that should be put in the pothole. Initially, that volume is assessed, it is given to a computer, and through the computer, the set quantity is mixed and then it is poured with the heat. It is poured to the pothole and thereby it is filled. This project we have taken up with the help of NCC, and the other one also, whichever you mentioned now, be it the shifting of the bricks or the plastering or the tile laying, all these things, I think some automation can be done in that area also. Definitely, yes, sir. We will think and we will act on that.
I'm very happy to see that, sir.
Yeah. Thank you. Yeah, we will do that.
Yes, thank you so much.
Yeah.
Thanks a lot.
Yes, sir. I am sharing. Is it come, sir? Video?
Yeah, no, we have not seen the video. We have seen
video did not come. You share the video.
Oh, no.
We are able to see your screen.
Okay, sir.
Yeah. Play the video.
Yes, sir. Is it coming, sir, now?
Yeah.
Yes.
To Kumar. MP4. Yeah.
Yes, sir. Same.
I think you have to give volume there, I think, no? Sir, this is one of the team which has won the second place in the international robotic competition.
Oh, very
held at Delhi. Yeah. They are called the war robos.
Oh.
Robos fighting each other.
Wow.
I think the students from mechanical engineering, particularly one Mr. Mintu Kumar, and that lady is Kavana. She is also a mechanical engineering student. they went to Delhi and they presented under the guidance of that striped shirt, Dr. Biswajit Pal. He is a faculty in our college. He has guided these students, and these students have done excellently well.
Congratulations.
And the fighting one, is it not there? That 20 or 30 seconds, Kapilan?
Yes, sir.
Yeah, that 20 or 30 seconds with the final fight with the other one. Sir, in the war robots, there are quite interesting things that we should study. One is the weight of the robo should be more. If the weight is more, the battery and the energy consumption also will be more.
Correct.
If the mass is not heavy, then it will not push the other robo. This robo itself will be pushed, and therefore you need to make it as robust as possible, but as lighter as possible or as stronger as possible. So therefore there are a lot of such interesting facts.
So
They have won the second prize. Yeah, you have that video there? This is the photograph, no? Video.
That video you don't have, sir.
You don't have that? That fighting one, it would have been interesting actually, how the robo will fight. Sir, very interestingly, see, when you have to give the energy to the robo, either through a cable you have to give the connection, or the battery itself should be enough to support that.
okay.
So, a lot of such key points are there, which the students have worked out and they have won at the international level.
Maybe he can share with us, sir, the video.
Yeah,
You can share that, yes, sir.
Sure. That we will do, sir.
Yeah.
That we will do.
Okay, sir.
Thank you all the panelists. Kapilan, shall we conclude?
Yes, sir. Yes, sir.
Yeah. Thank you all the panelists for your excellent knowledge sharing and the time that you have spent with us. These activities, the webinars and such other activities should continue. Particularly the COVID has taught us all these things. So life is a learning exercise. Every day we keep on learning. Let us learn. Let us join. Let us share our knowledge. Thank you very much for joining us. Thank you.
Thank you, sir.
Thank you, sir. Thank you. Thank you all. Thank you all, gentlemen.